Hi, today we're going to look at right triangle trigonometry. Many things in real life can be represented with a right triangle, and so there are some certain properties of right triangles that we want to look at. In geometry, you've learned probably some things about right triangles, and in fact, perhaps what we're talking about today, you should have probably seen in geometry. Okay, so I've got a right triangle here that I am going to look at, that I've written some properties down on. So we've got the right angle, that's down here. And then I've given you another angle, it's a 30-degree angle up top here. And then what I've done is I've given you the side opposite of that right angle, or of that 30-degree angle. And I told you that that side is 5 units long. And then the hypotenuse, remember, is always across from the right angle. So the hypotenuse is 10 units long. All right, so what I've got here is a nice triangle with some measurements, and then I made a similar triangle down here. On the similar triangle, I still have the 30-degree angle up there, but I've stretched this triangle to be a little bit bigger, and so now the side opposite is actually 9. Now, what we've learned from right triangles is that as long as this angle is the same, if you look at the ratio of the sides, in a similar triangle, the ratio of the sides should be the same. So for example, in this top triangle, the ratio of the side opposite of my 30-degree angle, that's 5. So the ratio of that side to the hypotenuse is a 5:10 ratio. Okay, that actually would reduce to a 1:2 ratio, which is kind of nice and easy. It just means my hypotenuse is going to be twice as long as my short leg. All right, if you have a triangle that is similar, has that same angle measurement, still is 30 degrees, the ratio of the sides should stay consistent. So now in this bigger triangle, when I look at the side opposite, now it is 9 units. So the ratio of the opposite side to the hypotenuse, 9 to something, still needs to be a 1:2 ratio. Okay, and like I said, that just means that the hypotenuse is going to be twice as long. So what that means is that this right here better end up being 18 units long, because it's twice as long as the short leg. So what we're looking at then is the ratio always of the opposite side to the hypotenuse. In a 30-degree angle, that ratio will always be 1:2. As I change the angle measurement, that ratio would change to something different. That ratio is common enough that we gave it a name. Okay, the ratio of the opposite side to the hypotenuse is called the sine of an angle. And so you can look at what I have here. I've got the sine. It's actually spelled S-I-N-E, but this is the abbreviation for it. The sine of some angle, we use theta, it's a Greek letter. It just represents the angle measurement, and so for us, our angle is 30. So the sine of an angle is always the ratio of the opposite to the hypotenuse side. Now there's nothing magic about the opposite and the hypotenuse. I might be using different sides. And so if I was looking at, let's say, this side, we call that the adjacent side because it's next to the 30. So if I wanted the adjacent side to the hypotenuse, that ratio is the cosine of an angle, and it's abbreviated COS. So the cosine of an angle is always the ratio of the adjacent side to the hypotenuse. And then the last option would be if you were looking at the ratio of the opposite side to the adjacent side. That has a name. It's called the tangent of an angle, and abbreviated TAN. So this right here you need to jot down. You need to know what those ratios are. We actually have a nice little acronym up here to help you remember that. The sine of an angle is always the opposite over the hypotenuse. Cosine of an angle is the adjacent over the hypotenuse. And the tangent of an angle is always the opposite over the adjacent. So if you can remember SOH CAH TOA, that helps you remember which one's which there. So let's just look at setting some of these up. So if I have this particular triangle here, and I want to know what the sine of theta is. Okay, so I moved where my theta is. Theta, or your angle, can be either of the acute angles. It cannot be the right angle. You'll always have that separate. And then theta, which is what you'll do your sine, cosine, or tangent with, is always one of the acute angles. So I moved it down to here. So now it's this acute angle. So the sine of theta, remember, is going to be opposite over hypotenuse. So when I look at that, the side opposite of theta is B, and my hypotenuse is C. Okay, so that means that the sine of theta in this example would be B over C. The cosine of my angle, cosine is going to be adjacent over hypotenuse. So this is my adjacent leg. It's next to the theta. And then the C here is always that hypotenuse that's across from the right angle. So C is my hypotenuse. So adjacent is A, hypotenuse is C. All right, last one, tangent of theta. Tangent is opposite over adjacent. So opposite of theta is B, and adjacent to theta is A. So the tangent of my angle is going to be B over A. All right, so I thought I'd throw in some little practice, like ACT type questions. These are a couple multiple choice questions, and a lot of times on the ACT there's usually a quick, simple little SOH CAH TOA type of question on the ACT. It should be an easy problem for you to get. If you look at this first one, number 1, the tangent of theta. Okay, so what you have to know is you have to remember tangent is opposite over adjacent. So theta they put up here, so opposite of theta is down here, 4, and adjacent to theta would be 3. So the tangent of theta should be 4 over 3, or B. Okay, see if you can, once you pause the video, you try number 2. All right, that was kind of mean of me. That one was a little messier. The idea is the same. You start over with your cosine of theta, so cosine is adjacent over hypotenuse. From theta, adjacent side is 17, hypotenuse is 5 root 13. So you should have gotten this. Unfortunately, none of those are that because they went ahead and they rationalized the denominator. So it's kind of testing you on a couple things there. Do you know your trig ratios? And then can you rationalize a denominator? So I rationalized it. Should have ended up with this. So D should have been your answer for this. Okay, let's try another one. Okay, you try cosine of theta. This one should be a little bit easier. Actually, why don't you do both of these for me? Okay, so this next one was pretty straightforward there. It's just the cosine, which is adjacent over hypotenuse. So adjacent to theta would be 24. Hypotenuse is 25 because it's across from the right angle. Okay, number 4, a little bit trickier, not too bad though. Here's my theta down here. So this time they want sine, so that means opposite, so that'd be 16 over hypotenuse, so 16 over 20. 16 over 20 isn't down here, but if you reduce it, you get 4 over 5. Okay, so let's do some stuff where we are actually going to do SOH CAH TOA several times, where we're going to do what they call solve the right triangle. What that means is find all the missing parts. So every right triangle is going to have 3 angles and 3 sides. So there's 6 things to find, but they're going to give us 3. We need to know 3 things, and then if they give us 3, we should be able to find the missing other 3 things. So let's look at this example. They give us 2 angles and 1 of the sides. Now, if you remember from geometry, anytime you use a capital letter, so I'm getting away from the theta idea now. Theta is just a Greek letter. Sometimes as you advance in math, you'll tend to use those Greek letters more. In geometry, you usually just named an angle with a capital letter. So right here, since this is a capital A, that's an angle measurement. This is an angle measurement. But this is a lowercase b, so it's a side measurement. And the angle and the side across from it are always the same letter. So let's look at this one. I've got an angle that's a 90, so I need to know that it's a right triangle, so typically that's going to be one of the things they give us, is that one of those angles is a right angle. So I'm over here. Let's just draw this out. Doesn't really matter how you set it up, just make sure you get a right angle in there. And my right angle is A. And the side across from that is always the lowercase letter, so that's going to be A. Now where I put B and C doesn't really matter. I'll put B up here, which means the side across from that is little b. And I happen to know that little b is 5 units because they give that to me. All right, and then the other angle has got to be my C value, which they happen to tell me is 72 degrees. Let's see if I can squeeze that in there. That's 72, that angle measurement. And then that means the side across from that is little c, which I do not know what that is. Okay, so what I'm missing then is, looks like I'm missing angle B. I don't know what that is. That's the only angle I'm missing. And then I'm missing little a, side A, and little c, side C. Those are the 3 things that I have to find. All right, so in this example, I kind of got lucky because they gave me 2 angle measurements. That makes life easy on finding the third one, because remember from geometry that the angles in a triangle have to add up to 180. So if I've got a 90 and a 72, I can just subtract those from 180, and I end up with that last angle has to be 18 degrees in order for that to all add up to 180. All right, so now we're going to go find little a and little c. So I'm going to just start with little a because it's next on my list here. And what I'm going to do is set up SOH-CAH to try to find that. Now, to do SOH-CAH, you have to use one of your acute angles. So I'm not going to be using my 90. I'm going to use the 72. I kind of like to use the angle they give me rather than the 18 that I found, just because if I happen to do something silly and goof that up, or if I ever did any rounding, I'm better off to use what they gave me. Okay, so we have angle C that we're going to end up using. So that's this 72 right here. If I'm going to look for little a, that's the hypotenuse. And then I'm also going to use the other thing that they gave me, the 5. Okay, and that is adjacent. So you have to remember your SOH-CAH. You have to know those. You got to be able to spell SOH-CAH. So when I look at this and I decided that I had the hypotenuse and the adjacent is what I was working with, because I knew the adjacent and I'm looking for the hypotenuse. Adjacent and hypotenuse is cosine. Okay, so cosine of my angle, so I'm going to set this up. Cosine of my angle, which I happen to know is 72 degrees, is going to be equal to the adjacent, which I know is 5, over the hypotenuse, which I do not know. Okay, I usually like to set this up as a quick little proportion where you just take the cosine of 72, put it over 1. All right, and then what we can always do if you look at that, because sometimes you're going to end up multiplying, sometimes you're going to end up dividing. If you just set up a quick proportion, you can just glance at it and see what you're supposed to do. So in this case, I'm going to cross multiply this direction. Basically, okay, so let me backtrack. Just make sure that we're all on the same page because we're going to do a lot of this. So you're basically doing cross products and you're saying that this product is equal to this product. So 5 times 1 is 5, and the cosine of 72 times A is A cosine 72. Okay, since I'm trying to solve for A here, I'm going to divide both sides by the cosine of 72. And then that crosses off, and I have my A solved for. Now, what I'm really going to be doing, though, is I think by the time we're in college algebra, we could probably do some of that little step in our head. Basically, what we're doing is we're taking 5 times the 1, because you have those two numbers, you're going to multiply those, and you're always going to end up dividing by that thing that's multiplied by your variable. So in this case, I'm going to end up dividing by the cosine of 72. So the way I look at that is I cross multiply what I can, and I divide by this other number. So in my calculator, I'm going to take 5 times 1, which I know in my head, that's 5, divide by cosine of 72. Real quick before we get too far, if you're using a graphing calculator, as I assume most of you are, there's one thing that you need to set in your calculator right now. You need to go to your mode, And you need to make sure that you are in degree mode, because all of the angles we are working with will be in degrees. But as you advance in trigonometry, you actually start using a different measurement. Rather than measuring angles in degrees, we can measure them in radians, which is a conversation for another day. But you want to make sure you go to your mode and make sure that you move it into degree mode. Anytime you're doing SOH CAH TOA, you got to be in degree mode. It will default to radian mode, so every time we clear our RAM, it'll go back to radians. So then you'll want to change it back to degrees. Okay, so then in your calculator, you're just going to take 5 and you're going to divide it by the cosine of 72, and you get 16.2. Actually, I'm going to go 2 decimal places on everything. So and now I know that my side A here is going to end up being 16.2 units long. All right, so let's try it one more time. Let's do little c. So I go back to my picture, and I'm looking for little c now. I'm still going to use what I knew. I'm still going to use the 72, and I'm still going to use the 5. So from angle C, from that acute angle 72, C is opposite, 5 is adjacent. Opposite and adjacent, that's tangent. So I'm going to set up the same kind of scenario, only this time it's going to be tangent that I'm using. So tangent of my angle is equal to opposite, and opposite of 72 is C, adjacent is 5. Put the tangent 72 over 1, and now I'm going to look at cross multiplying and dividing. I cross multiply the numbers that I know, so I'm going to cross multiply this way and divide by the other number. So I'm going to end up dividing by 1. So cross multiply, divide by 1, that's really not going to do anything, but let's go ahead and type that in our calculator. So 5 times the tangent of 72. Your calculator will always open parentheses. When it's doing the tangent of your angle, you always have to make sure that you close that parenthesis before you do anything else. So 5 times the tangent of 72 is 15.4. Divided by 1 isn't going to do anything. So I know that C is going to be 15.4. And that was the last thing that I needed to find. Those were the 3 missing parts. That's what I was able to find. Okay, let's just try this a couple more times. Okay, so here's another one. Pretty similar to that. I've got 2 angles and the side. And so if it helps you, go ahead and draw the picture. So I'll come over here and I'm going to draw this out. And A is the right angle, so that's right here. And that was given to me. And you can pick wherever you want C to go, doesn't really matter, so I'll just put it up here, and that means B is down here. And I know what C is. Angle C is 24 units, or 24 degrees, sorry. And the side C, which is opposite of that, is 5 units. And so then what I'm missing is little a over here and little b right there. And angle B. All right, so you set this up. Let's write out what we need to find. We need to find angle B. We need to find little a. We need to find little b. And again, I'm in luck because they gave me 2 of the angles, so it should be easy for me to find the third angle. I'm just going to take 180 and subtract those 2. So that gets me 66 degrees for angle B. And then I'm going to set up some SOH CAH TOA. Write this at the top of your paper so you don't have to rewrite it every single time. Or memorize it, that'd be good too. Okay, so now I'm going to look for little a. And I'm going to use what they gave me. So I know it's the 90 here, but I can't use my right angle. I always have to use my acute angle. So I'm going to use C. That's up here. So C, and I'm going to look. Oh, and then the other thing I know is this 5. Okay, that's opposite. And then I'm also going to look for little a. A happens to be my hypotenuse. All right. Opposite and hypotenuse, that's sine. Okay, so let's set this up. So the sine of our angle is equal to opposite, which I know, over hypotenuse, which is what I'm looking for. Put it over 1, cross multiply the two numbers that you can, so it's 5 times 1 divided by sine of 24 gets me 12.3. Okay, so that's, oh, I was going to go 2 decimal places and then I didn't end up doing that, did I? Okay, so 12.29 is actually what that ends up being. Okay, then I'm going to go find my other side. My other side is B, so I'm still going to stick with what I was given. So I'm still going to stay with angle C and the side opposite, but this time I'm looking for little b, and that's the adjacent side. So opposite and adjacent is tangent. So let's set this up. The tangent of the angle I know, which is the 24, is equal to opposite, which was 5, over the adjacent, which is what I'm looking for. Okay, so then I'm going to cross multiply. Works very similar to the last one, only this time it's the tangent of 24 that you're going to divide by. So 5 divided by the tangent of 24 should give us 11.23. All right, so that's kind of the gist of it. That's how we're setting these up. Let's look at a different type of problem, because on this one I'm kind of given some other things. Like if you'll look at what I've given you, instead of giving you 2 angles, I've only given you 1 angle, and it's the right angle. So I'm not going to be able to do SOH CAH TOA on that, because it has to be an acute angle. So here's my angle C, and I know, okay, so that one was given to me. I know that that's a right angle, and I know the side across from that is little c, and that's 22.3. And then, I don't know, put A and B wherever you want. Okay, and so the other thing that they gave me is little a. So side A is across from angle A, so that's 13.5 right here. And then I'm going to be looking for this little b here. All right, this one is approached probably a little bit differently because of what they've given us. I am missing angle A, I am missing angle B, and I'm missing little b, side B. So this goes back a little bit to geometry on, think about this for a minute. If you know 2 sides of a right triangle, can't you do Pythagorean theorem to find the missing side? Okay, so this time my first step is to do that. They didn't give me 2 of the angles, so I can't do the whole subtract from 180 to find the other angle. So instead, I'm going to work on my sides because they gave me 2 sides. And I'm going to do a Pythagorean theorem step to find that missing side. So remember, it's a squared plus b squared equals c squared. But be careful with that. A, b, and c can change. You just have to remember that this is a leg, and this is always your hypotenuse. Now, this particular example, we're in luck because my hypotenuse is little c, but those letters change, so don't get too caught up on the a, b's, and c's there. The 2 legs squared should add up to be the hypotenuse squared. So in this example, I'll let my a be the 13.5 squared plus b squared should equal 22.3 squared. Okay, so I'm going to take 22.3 and square it. And then I'm going to subtract 13.5 squared. And so then b squared is 315.04. And then I'll have to square root both sides. Normally, remember that we do plus or minus, but since you're talking about the side of a triangle, that can't really be negative, so we would only use the positive value. Side B is going to be 17.75. Okay, so we've got one of the sides, 17.75. Okay, so now what I'm missing are my two angles. I can't subtract from 180 because there's two of them missing. I'm just going to go back. I'm going to do some SOH CAH TOA. I'm going to have to use the two sides that they gave me. So I'm going to be using A and C. And I don't know, let's just start with angle A. And let's look at what that is. From angle A, I know the opposite and I know the hypotenuse. Opposite and hypotenuse would be which trig ratio, do you think? And you're saying, oh, well, that's sine. Okay, so sine of my angle, but this time I don't know the angle, so I just write sine of A is equal to opposite over hypotenuse. Now this is set up a little bit differently because I'm looking for my angle and I have to get rid of this sine. Now it's not like it's multiplied right here. This is not multiplication. I'm not multiplying times A. It's a sine. It's representing, it's a ratio of angle A. And so don't try to divide by sine. That doesn't do anything. You have to do the inverse operation. Just like we square root to undo squaring, or we divide to undo multiplying. Sine, cosine, tangent, they have inverse functions also. They're actually just called inverse sine or inverse cosine. And on your calculator, it's always just second sine or second cosine. And so what we need to do here to get rid of the sine is we'll do the inverse operation. So in your calculator, you'll do the inverse sine. And basically this is how it looks. We don't typically write this, but you're basically doing the inverse sine, which is shown with a little -1. And then you're doing the inverse sine on this side also. So over here, those cancel out and you just have A equals, but all you're doing here is you're typing this in your calculator. You're going to do second sine to get your inverse sine. And then you'll do 13.5 divided by 22.3 and close your parenthesis and put equals. Okay, and so what that tells you is that your angle A is going to be 37.26. Anytime you're looking for your angle, so this is maybe what you want to jot in your notes. Anytime you're looking for the angle, like we did in this case here, I was searching for angle A. You always will use your inverse sine or cosine or tangent, your inverse button to find that. That's how you get rid of the sine and just get the angle. All right, so then what I'm going to do is I'm going to jot that down up here. 37.26 is that angle measurement. And now, since I have another angle, now I'm just going to subtract from 180. So I would just do my 180 minus the 90 that they gave me, minus the 37.26, and then angle B has to be 52.74. Okay, so that's a different scenario on how you set this up. Since they only gave us one angle and they gave us two sides, we do the Pythagorean theorem and we do the inverse trig function. Okay, last problem. And as promised, there's a lot of application to SOH CAH TOA, so you'll have some of these in your on your assignment. This one, it says that we have a ramp that's 20 feet in length. It rises to a loading platform that is 3.5 feet off the ground. What's the angle of elevation for the ramp? Okay, there's actually some laws in regards to, certainly with handicap wheelchair ramps, they have to have a certain slope, a certain angle there. You can't make it too steep or it's really not very helpful because you can't get up that ramp if it's too steep. And so let's look at what the angle of elevation for this ramp is. Now, before we get started, because you'll have some on your assignment that are angle of elevation, and then you'll have some that are angle of depression. Those are two different things, but let's just draw this so you see what's going on. If you have the angle of elevation, you are always going from a straight horizontal line, and it's going upward, okay? So this would be your angle of elevation. If it's something, okay, so this is like a ramp, or maybe it's you and you're looking up at the sky at an airplane or something like that. But this is you looking up or something going upward. The angle of depression is a little trickier. On angle of depression, it's like when you are in the sky and you are, like, let's say you're in a plane up here, and you're looking down, or let's say you're at the pilot and you're looking down at a house or something. Okay, so you still have to go with a horizontal, and it's always like from your eyes. It's your line of sight. So here's the pilot looking out this way. So that's your line of sight. And your angle of depression is you looking downward. So this is kind of weird because the right triangle is really, over here it's pretty obvious. Here's the right triangle that gets formed. Usually the way we draw these is you got the plane. Here's how high the plane is off of the ground. Here's how far like the horizontal distance, or maybe the runway or something like that is. And so this is the right triangle we usually draw. It's very tempting to want to call this angle here the angle of depression, but it is not. The angle of depression is actually this one that's not part of my right triangle. And so if they said something like you had an angle of depression of 10 degrees, what you would do with that is you would go say, oh, well then this, since I know that that forms a right angle up there, this would actually be 80. And that's what I would be using for my angle in my triangle. And I'd go do SOH CAH TOA with the 80 degrees. I don't really use the 10 degrees. So angle of depression, angle of elevation, always go from the horizontal upward or the horizontal downward. Angle of depression, be careful on that one. All right, let's go back to our problem. We have a ramp. Okay, so this one isn't really about a person looking up or down. It's just a ramp. So think about what that would look like. You've got this ground and then it's headed upward, and basically there's some sort of loading platform here. Okay, and it says that the ramp is 20 feet in length. Okay, that's this right here. This is my ramp. It's 20 feet. The platform is 3.5 feet off the ground. Okay, so that's the height of the platform. What's the angle of elevation? Okay, so how far up off of the horizontal did we go? So that's like my X right there. That's what I'm looking for, that angle measurement. Okay, so this is like our last problem because they gave us two sides. So I could go do Pythagorean theorem, but we're not really trying to solve this triangle. We only have to find one missing thing. We don't have to find all the missing things. We're just finding this one angle. Okay, so this is the thing where you had to do the inverse because you're looking for an angle measurement. So from this angle, we know the opposite side, and we know the hypotenuse because that's across from our right angle down here. So opposite and hypotenuse, which trig ratio? You should be saying sine. Sine of some angle, I'm just going to call it x, is equal to the opposite over the hypotenuse. All right, and so in my calculator, I need to get rid of this sine, so I'm going to do inverse sine of 3.5 divided by 20. Close the parenthesis. And I have an angle measurement of 10.08 degrees. Okay, so it's pretty close to a 10-degree angle for that angle of elevation. All right, that's all I've got for you. Hope this helps.